Now, I'm not going to use the Telecaster flatwork, you know, the big flatwork, because I'm not going to route out my guitar. That's not part of the plan, and I don't think it's even necessary. The essential characteristics of the pickup that Eddie was using were that it had 0.25-inch diameter slugs, that it had a DC rating, resistance rating of 12,000 ohms, that it probably had the plate underneath of it like a Telecaster bridge pickup does, and that can be bought even if it's not being used on a Telecaster shaped pickup. So what I've purchased is flatwork with 0.25-inch slug holes. I've purchased 0.25-inch slugs, actually in two heights, 0.65 and 0.688. We can noodle with that. I'm going to start by using the 0.65-inch. I've ordered a plate from Mojo Tone that can be installed underneath the Stratocaster flatwork, much like the plate is inserted underneath a Telecaster flatwork. And I've ordered a spool of 43 AWG enamel-coated copper wire, which probably was the wire used, because with 42 AWG, the girth of the wire would probably be too great, the wire would be too thick, too wide to get many turns onto the bobbin. So if we're going to try and get enough turns to get the resistance up to 12,000 K, we're going to need thinner wire. And thinner wire normally gives you higher resistance to begin with, and it allows you to put more turns on a bobbin. I can then go to the next step, which is adding that copper ribbon and grounding it so that we have a pickup that, you know, matches what Eddie had in terms of setup with the shielding on it. And we can see how that sounds, and we can see whether the Schecter approach of trying to shield the pickup from surrounding electromagnetic interference has any, you know, significant effect. I'm not going to make a tapped coil. I don't think Eddie's was a tapped coil. I don't see any evidence for that. But what I am going to do is I'm going to try and wind as much 43 AWG wire onto that bobbin as I can. I'm then going to measure the resistance of the pickup. I mean, if it's 18,000, then great. Or if it's 16,000, better, because that's what the resistance was of the Schecter F520T in the full coil position. But whatever the count, I will at least know that I have this many turns on the bobbin, and I have this resistance, and that should allow me to reduce the number of turns to the point where I expect to have an output DC resistance of approximately 12,000 ohms, and that's what we're targeting, because that's what Schecter says was in its non-tapped pickup. So here's the regular route for a Stratocaster pickup. This is the route for a humbucker pickup. And Eddie Van Halen wanted to put a Telecaster pickup here. The problem he had was that Telecaster pickups usually go in the bridge. This is a bridge pickup we're talking about. They would usually go in the bridge on an angle like so. The route would be shaped pretty much the same as this, and it would be on an angle so that when it's lined up with the strings, you know, a string would go over each magnet of the Telecaster bridge pickup. Eddie wants to put this in his guitar in the middle position, and we also know he doesn't care too much about these two positions. He mostly wants to make sure that the E and the B strings line up with these two magnets, so he's going to pull it this way a bit. And then he's going to say, well, gee, it doesn't fit. It has to go in. So what does he do? He takes a router to it and routes an opening, a little bit out of the bottom, a little bit out of the top, so that he can get a Telecaster pickup into the hole. And that's why when you buy a stock, I think they call them Frankie Striped Series guitar, which is close approximation of a Frankenstein, they still do the route right here. They cut an unusual route here, and they cut some down here. It kind of looks a little mangled, and that's because it's a cut that was used and necessary for putting a Telecaster base plate in to the hole. So instead, we're not using Telecaster. We're going to do Stratocaster, and we're going to, you'll see this is the Stratocaster piece here. It'll fit right in there, no problem. And we should be able to get essentially the same sound with this base plate as with that base plate. They're not, these base plates aren't, you know, they're not active in terms of their sound. They're only important in terms of, you know, the height between the bottom and the top piece. This is the bottom piece, and this is the top piece. And these two pieces are going to be like so, one above the other, with rod magnets in here. Now these are unusually large. These are the 0.25 inch holes. So for the 0.25 inch slugs, which I purchased. So first thing we're going to do is make our bobbin by pressing the 1/4 inch rod magnets into the top and bottom flatwork. This is called flatwork. And then we'll have a start for like a bobbin for winding a pickup on the machine. All right, so let's have a look at our parts. We've got a metal base plate that'll be glued onto the bottom of the flatwork. We've got our bottom flatwork. We've got our top flatwork. We've got a bag of Alnico 5 1/4 inch slugs, so we'll need 6 of those. And what we're going to do is we're going to press the slugs into the flatwork using the press we've got here. We've got a bit of rubbish that's left over from the flatwork. Now these slugs, these rod magnets, aren't really magnets yet. They're just slugs of Alnico 5 alloy that will eventually be magnetized when I put them in between the two neodymium magnets, which I'll show you in a bit. All right, so I've got the X-Acto out. I can just take away a little bit of this material here that seems to be, it just picks away, really. All right, I think that's looking good. Let's try putting our top on. All right, so we'll just do a little clean up with this, like we did on the bottoms. All right, so we've got our bobbin here. I still might do a little bit of cleanup on this one here, but I don't need to film all of it, so. So that's the top, side, bottom, and basically what's going to happen is these aren't magnetized yet. So first we're going to wind the coil, then we'll magnetize it. There will be a start wire. Well, first we're going to put this tape around here that prevents corrosion between the magnets and the wire, but then we're going to have a start wire, meaning where the coil begins, and we're going to have after winding it, the coil will come back out, or the wire will come back out and go around this eye right here, and they'll be soldered in, and then we'll put our leads leading out to the control cavity into those holes and solder the leads into the holes. Just a quick word of warning if you're doing this. These plates, the base plates, well, that's not really the base plate, just the bottom part of the flatwork, has these two eyelets. And one side is, you can maybe see it's kind of protruding. The other side does not. And that's because when you're winding this thing, you don't want the wire to get caught on any protrusions. So make sure that when you're putting your base plate on, or your bottom flatwork on, that the protrusions are on the bottom, not on the top. So this is what I'll be using to insulate the magnets from the copper wind. It's called Kapton, not captain as a captain of a ship, but Kapton tape. It's got a coppery look to it. But it's actually clear. So this is how it looks on the spool, and this is not quite as wide as the space there, so we're going to have to go around a couple of times. Good. This device here, which from 8 inches away allows you to basically see, I think 2.5 times the size or something along those lines. So that's what we're going to use. This is called an Optivisor. It's not too expensive. Got it on Amazon. This is going to be 43 gauge plain enamel wire that we're winding onto this bobbin. 43 is smaller than 42 gauge, and 42 gauge would be used on, say, a humbucker normally, like a regular strength humbucker, not a super heavy hot wound one. And we're going to give ourselves a few inches to play with here. Oh, but the other thing is, because it's plain enamel wire, we've got to sand the enamel off. It's just a piece of sandpaper. I'm going to pull my visor down so I can see the wire. And I'm going to assume that, oh, let's say there'll be some cut off. So I'm gonna sand about from here. And I'm going to mark with my finger, just keeping my finger there. I'm not pinching the wire with my fingers, I'm pinching it between the paper. It's hard to see. I'm just going to give this a few strokes through. We're going to mark this as that length. Basically to the screw on these scissors is how much is exposed wire, is not, so we're going to make sure all of that comes through. I'm going to go one more time for good measure. I'm going to take this wire, put it on the ground. We're ready to wind. I'm going to put some white toilet paper here, is the thing I've been finding handy. I put a light behind so I can see the wire. To get 12 K ohms, I'm going to try and put 12,511 turns on there, but I've already probably put about 11 turns on there just by fiddling with this sizing up. So just get my winding glove, if I can call it that. Just a cotton glove. Got a pair for $3 at Shoppers Drug Mart. And set up the program. So not the same as last time. We want reverse direction, counterclockwise. Except that turns, we're going to go up, way up. And there we go. So I'll just give you a quick look at that. That's the tape side. untaped side. Looks fairly neat, tidy. And this is our start eyelet. So this is our finish eyelet. The wire's going to come through and go around there. I'm going to sand from about that point onward. I'm not going to sand anything prior to it. The little piece of tape came off, but that's okay because I've got this black tape on here now that'll suffice to hold everything in place. So I'm going to put my optivisors on and sand. We'll pull the wire through this eyelet, and then I'm going to sand the length. Then I'm going to wind it around just like I did with this eyelet a number of times, and then we're going to take out the cables that will go, or the wires that will go from the pickup back to the control cavity of the guitar, and we'll solder them into these eyelets. Should be good. The idea is I'm going to have to strip some of this wire so that I have a piece that hangs out that can then be soldered to the back of the base plate after going through the eyelet. There we go. I don't think I could pull it back sufficiently. There we go. Good. Okay, so what I want to do is test now to see if we've got continuity. And that's almost exactly where we want to be. I want to be at 12 k ohms. I'm at, what, 11.75? Oh, I'm so happy. I went to 12 right there. Look at that. Ah! Awesome. Nailed it. So before taking this any further, what I'm going to do is protect the coil with some black paper tape. It's designed for pickups. The width of this tape is pretty close to the height of the bob, and it's 12 millimeter. I think the height's probably 15 millimeter, but I don't want to put too much on there because with this pickup design, it's got a copper coat that's going to be wearing. But I do have some wire exposed still, so I'm going to make sure that I go over that. Besides that, the copper ribbon I'm going to be putting on is soldered to itself. And I don't want the heat messing with the coil. Now that said, because this is plain enamel wire, the heat should not melt the coating off the wire. All right, so now we've got a coil that all the way around has some black tape to protect the coil from, who knows, fingernails, gosh knows, whatever might grab them. So that's protected. So I think the next step here that we'll take is to attach the base plate to here. Now, I've seen where people have crazy glued these to the back. I've got 10 of these plates. I suppose I could always pry it off if this whole thing went putz. And so I'm going to use that approach. We're not trying to create an electrical connection here. We're just trying to create a magnetic one. We have the plate on here now. It's super glued to the tape that's attached to the bottom of the pickup. If I had to, I could still rip the plate off. It's not a big deal. And once the magnets are magnetized fully, they're going to be pulling on this plate anyway. The plate's not going to want to go anywhere. So I've left right here about 3/4 of a centimeter of wire. That's going to be bent down to touch here. I'm going to put a puddle of solder down first, and then I'll heat the two together, and it'll make a good contact with the steel plate. Just heating up the iron right now. Now, after I'm done this, the next thing is to put a ribbon of copper around the coil. It's a ribbon of copper that's meant to sort of block electromagnetic interference that might otherwise hit the coils and add to the hum created in a single coil pickup like this. It was an innovation of Schecter pickups, at least back in the 1970s. You could see their pickups typically had a copper ribbon around, and of course the Stratocaster pickup in Eddie Van Halen's middle position on the Frankenstrat, the red Frankenstrat, well, even before it was red, when it was just white and black, had that copper shielding. We can see the copper shielding in at least one photo, so we know it's a Schecter pickup. Let's just back off a little bit and have a look at this copper. And so I'm going to basically take a measurement around the pickup to see how long the ribbon has to be to fold upon itself. And I'm also going to have to take a good measurement of the distance between the top and bottom of the bobbins. Although I think I won't do it that way. I think what I'll do is I'll look at the specifications for the thickness of the top and bottom flat work. I'll look at the specification for the height of the slugs that I've got in there. I'll subtract the thickness of the flat work from the height of the slugs, and that will be my official distance from top to bottom for the copper to go around. It needs to go around a little bit over one turn because it gets soldered to itself and then also gets soldered to the base plate, or to ground in other words. So we're going to put this aside for now. We'll get the base plate grounded. Should be good by now. We've got our dollop. I'm going to press down this wire against the base plate right next to the solder. All right, so I have a concern. This pickup is going to have a copper ribbon wrapped around it, but a ribbon of copper is kind of like a circle of knife. And there are very, very fine wires, the start and finish wires, that come out from under the coil bobbin here and come to these contacts with the lead, which I've folded and put through the hole that's in the middle. I don't want to risk putting a copper ribbon anywhere near those two fine hair-like wires. So I've decided to do a slight buildup of a material that will coat the wires, hold the wires against the bobbin so they won't wiggle around and snap, and also protect them from downward pressure from a ribbon of copper. So what I've decided upon is JB Weld high heat. Now high heat because I'm going to be dipping this pickup in melted wax, and I don't want whatever I put on there to just melt in the melted wax. So high heat, I think it'll stay solid at something like 500 degrees Fahrenheit or something. It's pretty good. It'll do the trick. So what I'm going to do is, this is an epoxy. So it starts off very soft. It's even softer than toothpaste, really. And it comes out of 2 tubes. When the 2 combine, they form the epoxy, and it takes about 5 hours for it to set, another 15 hours or something to be hard. So I'm going to set it and forget it for a day. You turn this knob here, pull it out. Now you've got one black, one white substance. When mixed together, they're gray. And I'll mix the black with the white. To make it gray. It smells kind of like rubber, basically. All right, and so now I've got it mixed. I'm going to apply it to the pickup over top of those wires. I don't mind if I get a little bit touching the tape. That's not a problem. In fact, it's probably a virtue. So now I've got the one side. I don't know if you can see that. I've got the one side gooped. I'm now going to do the other side. And I want to go all the way from the where the wire comes out from under the bobbin, which is right about there, all the way to the contact, which is right there. And then I'm just going to do some cleanup on the bottom. Okay, I'm going to wipe that excess off the paper tape. Because that is where the ribbon's going to go, the copper ribbon. Looks good to me. Okay. We'll leave this pickup here to dry for the next 20 hours. And we'll come back and see this tomorrow. All right, here we are. It's approximately 15 to 17 hours later. The JB Weld has gone totally solid. And that's the case here as well. So those fine wires are now completely encased in a rock hard epoxy. So next step is making the copper surround. But before we do that, I thought we should check to see what noise the pickup picks up without the copper surround, because the point of the copper surround is to try and reduce electromagnetic interference, kind of like putting copper tape into your the cavity of your guitar. So only in this case, it's wrapped right around the coil. Whether it works or not, I have no idea. Certainly Schecter thought that it was a good idea to do with their pickups. They did it on all of theirs. Let's see if I can get some better light on the subject here. You can see where the goop is. All right, it's just a gray goop. Hard as a rock, so that's good. That's going nowhere. Those wires aren't getting severed by any copper I might put there. So what I've done is, I'm not going to put it in the guitar yet. We don't need strings to test noise. We only need electromagnetic radiation. So I've created this, just a piece of project board, for the kids at school kind of thing. In fact, I think this was used by my kids in school. And I just created a couple squares to hold it up, so I can hold it up like that. What we're going to do is attach the pickup to the display board so it can hold on to something. I can hold up or have the fake guitar, if you want to call it that, sit on near the computer, and we'll do what we did with the humbucker. We'll see what kind of sound we get without any strings, without having magnetized the, keep in mind, these have not been magnetized yet. So without magnetizing them, what kind of noise are we picking up? This is a single coil, not a humbucker, so it's going to be a noisier pickup in theory, and especially because it's a hot pickup. In other words, it's got a lot of copper. So it's potentially going to pick up a lot more noise from the surrounding area, and that'll give us a good baseline against which to test the effect of putting the copper around. So let's do that first. All right, so I've got just a couple regular wood screws. These are Robertsons, so I got a Robertson size, or a Robertson screwdriver. We're gonna screw the pickup straight into this board, but before I do that, I'm gonna make an opening for a jack. Wee bit bigger, son. There we go. If I can clear this garbage away from the edge of the circle. And then we'll put our pickup on this side. And there's a rock and roll guitar. Okay, now we just have to hook our pickup up to the output jack. This is even more Eddie Van Halen than Eddie Van Halen. Just a bit of anatomy on the jack. This piece here is attached basically to this piece here. When you stick the cord through, this will go into the notch at the end of your cord. This is where the hot signal is. The white wire is going to be our hot, and black our ground. And so we're going to attach the black to the ground lug, and we're going to attach white to the hot lug. And then we're going to heat the wire and the contact. And then just blast it with a little bit of solder. We're good. Same on the ground side. Great. Let's go see what kind of noise our guitar makes with no strings and no magnets. All right, so this is the same setup we used to demonstrate humbucking in that humbucking video. I've got my makeshift guitar here, which is nothing but a wound coil with unmagnetized or not magnetized slugs. And I've got an input jack, so we're gonna plug the input jack, or plug into the input jack, like so. That's my guitar, for lack of a better word. And it's plugged into the Focusrite, going straight into my laptop. And so we're going to hit record on this and see what kind of noise we get. It won't be audible in the room. It'll be audible only when we do a playback. So that signal, I don't know if you can see it or not. I'll do a zoom in. That's just the noise coming off of, well, any other devices in this room, but probably primarily the computer itself. Let me see if it's still the case that the computer is providing most of the noise. Well, there was a bit of a reduction there when I pulled the power off, but it's still very close to the computer. So whether the power's on or not, there's a bit of a boost when I put the power back to it from the wall. All right, so that's our baseline measure for the noise coming off of the single coil. And now let's apply a copper ribbon to it, as the old Schecter pickups did, and see if that changes the nature or the volume of the noise. The idea of it being just to shield the coil from whatever the coil is currently picking up to some degree or another. We can also plug straight into the little amplifier I've got over here. Let's try that. So if this were in a guitar, that's the noise you would be hearing from this room going through the amplifier. Let's just see if the amplifier is on very loudly. That's with the gain and the master all the way up. That's the master all the way up, but not as much gain. There's the gain full up. Of course, the gain is compressing the sound, so it's taking the quiet sounds and making them louder. All right, let's apply the copper ribbon and see if we remedy that at all. All right, so I've taken the height of the slugs and from that deducted the height of the top and bottom flatwork to give a space in between the flatwork of 0.533 inches. So we know that our copper ribbon has to be that tall, or whatever you want to call it. But what we need to do now is find out what the length is going around, and the copper ribbon needs to overlap with itself. I would say, you know, I'm guessing. I've never seen it unraveled, so let's say it's about 0.5 centimeter to 1 centimeter. I'll say 6 3/4 inches. All right, so we've got our measurements here. Put it back into millimeters. So it's 13.5 millimeters tall, and then 171.5 millimeters around, at least on my particular coil. And you can see how thin it is. That edge on my hand, 171.5. I'm going to use this edge, and that way we'll only have to cut one strip. We want that strip to be 13.5 millimeters. There we go. Okay, we'll roll this back up for future use, perhaps, in case any of you want me to make you one. It's a bit laborious, but might be worth it. We'll find out. All right, so we've got a strip. I'm going to smooth that out on the edge. Just going to be right there. There we go. But before I put it anywhere near the coil, I'm going to just sand the edge lightly of this thing. The other thing is that where the epoxy has been applied, it's not going to sit down nicely. So I'm going to have to take a little bit of material out just where the epoxy is. I'll decide how to do that after I sort of get a rough look at how it's fitting onto the bobbin. But first things first, a little bit of sandpaper. This is the 800 grit. Okay, those are not sharp edges. They're small edges, but they're not sharp edges. So let's get our coil out. Okay, so let's see if our copper strip is going to fit nicely around pickup. I am so glad that I put the epoxy in there, because I wouldn't want to be bringing this sharp edge near the those two lead wires, the start and the finish wire. I can form it a bit around the edges like this, so I know where the two extents are. Of course, I'm getting binding right there because that's where the epoxy and the wires are. But I think I've got the right height going on there. I'm not exceeding the top of the bobbin. And I've got a little bit of the bobbin edge showing. So no, I think we nailed it. I think that's good. So now what we've got to do is make this part accommodate this scoop. About, looking at the height of the epoxy, I'd say it's about to there. You know, I laugh. I watch this fella scout outdoors. He's a fella in Newfoundland, and he often doesn't have the tool for the job, and so he makes ends meet. And sometimes I criticize him for it or have a laugh at it, but here I am doing the same thing. Because frankly, it's probably the easiest way to do it, rather than, there's no specified way of doing this. So we're basically, what we're doing here is we're reverse engineering a pickup. Okay, there's one. Come on. All right. And again, I'm going to hit it with the sandpaper, get rid of any snags. All right, and I'm just going to smooth the whole deal out. Okay, let's get her back up here. Okay, good. That's now clearing the epoxy on that side. And that's clearing the epoxy on that side. Good. The ones I've seen, the pickups I've seen, the old Schecters, after they're wound like that, there's a glop of solder that goes on right there that attaches a ground wire to ground, so it'll come off of here and around and onto the base plate. But okay, first things first, let's figure out how to get this jobby to stay in place. You know, it's not even just a question of having it attached to itself. It's also a question of making sure that once it's on there, it doesn't slide up this way. How they did that with the originals was they had a top flatwork that was oversized. This is not oversized, so I don't have the luxury of winding winds of copper on here and then still having enough room underneath the top flatwork to get this thing held in. All right, so I think I've got a simple solution to the steps in soldering the ribbon onto here. I think the first thing to do is simply to crazy glue this side, not the side that's going to be soldered, but this side, the inside, along the opposite side from the soldering side, to crazy glue it down there. That'll fasten the copper this way. It won't want to climb off. Then I can turn it around. I can crazy glue the corners, leaving these two flaps Four little drops should be enough. All right, so it's more than 10-15 minutes, actually a while. We can take our heavy StewMac ruler off. got. All right, so now we've got, that's on there nicely. And we've got our 2 pieces of copper here. Now before I glue these down, which I am going to do, like so, okay, I'm going to tin the ends of this. The way that this is going to happen is we're going to apply flux, which is like a jelly or paste, here, here, and again on the other side of this end, but not on this one. Let's double check that. Sorry, this is the side we're going to do both sides on. This one here, which is going to lay against the tape of the coil, we're just going to do this upper side. We don't want flux on the back of it. And then we'll tin it, meaning we'll apply some solder to it before we glue it down in place. And last of all, we'll solder those 2 ends together. So I'm just going to start by sanding a little bit until we get what's called baby pink. The copper just has its sort of oxidized outer layer sanded off. You can kind of see it's a bit different. I'm not going to go too crazy with it. It's basically just there to clean the surface and make sure that the solder is going to make a good contact. Now, I don't need a big overhang or a ton of flux. I just need about that much. Unfortunately, I don't have a wider bit than this, but that's all I'm going to do right there. There we go. Okay, so next I'll glue this in place in the anticipation that after it dries, we're going to solder these 2 together as so. Okay. So let's choose our glue spots here. I think first we'll add some right on the ends, and then 1, 2, 3, 4. And then I'll leave it for another 15 minutes or so. No need to rush. It's going to be a bit tricky. I might just hold it by my hands for a few minutes. I think that'll be safer. I did try to contact Dylan Talks Tone, who manufactures flatwork, and see if he might be able to make me some flatwork for this for these 25-inch slugs that had more of an overhang, so I wouldn't have to rely upon chemical solutions to prevent it from sliding up and down as much as I have to in this case, but I didn't hear back from him. He's probably very busy. So pretty sure he has the ability to do it. I think he's got the technology. He's now got a laser that can basically cut any, like flat work to any shape or size, and all the holes and everything else with quite a bit of accuracy. I'm going to say that that crazy glue is probably doing its job now. So since I've got my soldering iron in place, I am going to do the job. This is the part that scares me the most. I believe, sirs and madams, that we have success. Let's just see if we can wipe off any excess flux. We have our ribbon wound pickup. And all we have to do is attach a lead from here to the base plate so that we've grounded it. So let's get that done. Let's see, go to about there. Just a single strand of copper. And so I'm going to attach that to the copper shield here. All right, that'll have to do. It's not a beauty contest. Woo. She's a hot mama. All right, that's it. That pickup is built. Here it is. Not the prettiest sight over here. I might have to clean that up a bit. But that is effectively the equivalent of a Schecter F520N pickup in terms of its DC resistance, in terms of its construction, with the difference being, of course, that this is not tele flat work, this is strat flat work, so it's narrower this way, and actually the pole pieces are closer together than they would be in a Telecaster. But other than that, it's the same pieces. It's the 0.25-inch slugs. It's the copper ribbon around the winds. It's the the 12,000 DC ohms resistance. So we've got ourselves our middle pickup. All I have to do now is magnetize the slugs north up. But before we do that, let's go see if there's a difference now in the noise that is picked up by this coil now that we've got the copper ribbon on it. All right, so now we've got the copper ribbon on the pickup. I can plug it in our makeshift guitar here, and I'll start up the Audacity. I'm seeing more volume anyway, more sound. We're going to run a little experiment. This is the ground wire that takes the copper shielding, or copper ribbon, attaches it to the base. The base is attached to the ground wire right there. Okay, so the black wire not only is attached to the eyelet, but is attached to the base. So the black wire is effectively connected not only to the coil inside, but to the copper shield, and the black wire goes to ground, the white wire goes to hot. What I propose to do here is disconnect the copper shield from ground here, insert a switch so that we can take it in or out of the circuit and see what it contributes to the overall noise. So we can put this in a makeshift paper or cardboard guitar and see what kind of EMI we're getting when we put it in or out of the circuit. Okay, so I've removed the connection between the copper shield and the base, and so we're going to insert a switch. Here we go. We're going to put a switch. This is double pull, double throw. I'm going to connect it so this will go to the ribbon. This will go to ground, back of the pickup. And that will go to nothing. So if the switch is where it is right now, it will be connecting the middle to nothing. And that means that the ribbon will not be part of the circuit. Nothing will be part of the circuit. It'll just be a wire heading to ground. And when I flip it, the copper ribbon will be put into the circuit, added to the circuit here on the ground. And we'll see what happens when we ground a copper ribbon that's surrounding a coil. That's one. And there's the other. All right, so we'll just attach the one lead to the ribbon. Kind of difficult to do this around the camera on all weird angles, but let's give it a shot. There we go. Good. All right, so now we'll connect the other end, the other wire rather, to the base plate. That'll complete the circuit when we flip the switch into the closed position. It's hard to get a lot of heat to this base plate. It's there we go. All right, I'll put our jack together. And I will solder it. I don't like soldering these things when they're just using a test situation, but if you don't solder them, as you'll see in other videos in this series, sometimes you get this jiggling connection and you don't know if you're hearing a bad pickup or a bad connection with the wire. So I'm just gonna potentially sacrifice a jack. A little flux never hurts. There's one. There's two. Good. And now we can assemble this thing. All right, so we've got our, this is the copper ribbon. Either it's in the circuit or it's out of the circuit. Currently it's in the out of the circuit position. And we can attach our pickup like about there. All right, we've got a pickup, we've got a switch. We need a jack. Where are you, Jackie boy? There you are. There we go. All right. That's our guitar. Let's go test it out. All right, so we've got our little Yamaha amplifier. We've got our guitar, no strings attached, as it were. We've got the copper shield in the out of the circuit position. We're going to plug it in. Oh, guitar all the way up. So that's just guitar volume versus if you wanted to plug in, like, I don't know, your iPhone for the audio or whatever, you could do that. Anyway, we got the guitar up at 10. We'll crank the gain, we'll crank the master, we'll crank the bass in the middle and the treble. We'll keep the effects off, of course. And we'll use the clean channel. Okay, now nothing's plugged in yet. With some feedback, so we know the pickup's working. Anyway, I'll turn that gain down. How about that? So we'll move the amplifier away from the pickup a little bit. Copper's out of the mix. Copper's in the mix. Okay, so we know that the noise we're hearing is actually from the pickup itself, not from the amplifier. Here's the amplifier. We're not getting an appreciable difference in that is microphonics. Let's try clipping this all together and seeing what we get. Okay, won't take any, change any of the knobs, we'll leave them the same. We're just going to clip the wire. That takes the switch, and this one here is the return, okay? So the switch is out of the circuit entirely, all right? So there's no connection between the copper and the back plate. Plug it back in. Exactly the same. Let's try one other thing. Let's run a wire straight from the copper ribbon right to the output lug, the sleeve lug of the output jack. All right, now we're connected to the sleeve lug directly from the copper, and that means it's going straight to ground. So let's give this another shot. Break the link. No difference. I think we can safely say that this copper ribbon is not taking any electric field interference and sending it to ground, but that was the spec for the Schecter. All right, so why doesn't the ribbon of copper work? Well, what are you asking it to do? We've talked in a previous video about humbucking, and that's where you've got magnetic fields that are causing a current within the coil, and so you put two coils opposing one another, and because those external magnetic fields are affecting both of those coils in opposite directions, when we wire them against each other, they cancel out that noise from the magnetic field interference and leave the signal that's caused by the strings moving through the magnetic field of the pickup itself. But we've talked about, you'll hear people talk about electromagnetic interference. And that's kind of the combination of two things, not just magnetic field interference, but electric field interference. Electric field interference is different, and it's not canceled by humbuckers. So you'll recall in the description of, well, in one of the earlier videos in this series, we were talking about parasitic capacitance. And so that if you wind a pickup such that the turns of the wire are lying right on top of each other like that, as opposed to, say, scatter around, they effectively act like a capacitor, and that decreases the resonant peak of the pickup. Okay, Well, there's also capacitance between electrical cables. You know, there's current running through cables all around you. Maybe you're at a concert, you've got lighting cables and all these other cables, and there's electrical current moving through them. And imagine that, you know how with the wire inside a pickup, we've got a coating on the wire that prevents the wires from actually conducting electricity by touching one another. But that coating acts like a dielectric in a capacitor. And so that's where we get the capacitance among the turns of the pickup wire. Okay? Well, same thing happens with air. Air acts like a coating on wire. And it's a dielectric between the electricity moving through the surrounding wires, the wires that are used to light your stage and everything else, and the wires in your guitar. All right, so you might ask yourself, well, why wouldn't the copper ribbon do the same thing? We've got the coil wrapped in a copper ribbon. Why doesn't it sort of capture that electric field interference and send it to ground if we've grounded it? Well, the answer is a pickup coil is a low impedance part of the puzzle, part of the whole circuit. Think of it like low resistance, but it's more complex than that. But let's just think of it as low resistance. So you might have like a, 14 k ohms at the best. But from the point at which the coil exits, and there's a cord that goes into your control cavity, a cable that goes into your control cavity from the pickup, then you go through, potentiometers and a jack and out to your amplifier, which is a very high impedance device. Well, it turns out that although the pickup itself, the coil, is low impedance, all that circuitry in your guitar, the cords or the cables connecting the pots and connecting the pickup to the pots and etc., those are relatively high impedance. And when they're relatively high impedance, those small capacitive effects from those surrounding wires are more audible. They have a bigger effect on the voltage that's going to your amp, and it's the voltage that is the source of the sound that gets amplified and put through your speakers. So the electric field interference doesn't really happen within the coil. It happens after the coil. It happens in your electronics. So you can even build a Faraday cage around your coil. It's possible, but it would be a waste of time because electric field interference is not created audibly by electric fields interacting with your coil. It's caused by electric fields interacting with the rest of your electronics. So you might say, well, why would, Schecter put a ribbon around the coil if the coil is not the thing that's generating the electric field interference? Marketing? Possibly it would have an effect on high frequency response of the pickup. But that's not how Schecter advertised it. They talked about shielding from interference. So I think it was either they didn't know that the shielding wouldn't do anything, or they thought that it would be a good marketing ploy. But it did not have the effect, as we've demonstrated in that experiment. You can take it in, take it out of the circuit. That ribbon does not change the audible noise. And even if we made it a Faraday cage around the coil, it wouldn't change the noise because the noise isn't coming from the coil. Electric field interference is coming, if at all, through the electronics. So in the experiment, we didn't have any shielding at all around the wires that lead from the pickup to the jack. That was all just sitting out on a piece of cardboard or whatever you call that, press board that we used for the guitar. It was completely exposed to whatever electric field interference. If we had a way of putting all that into a Faraday cage, we possibly could have quieted it down. But it's the electronics, not the coil of the pickup, that we would have had to surround in that Faraday cage and then ground. The one other thing we want to make sure we don't forget, because magnetic field interference is one thing and electric field interference is another, it's also the case that humbucking does not deal with electric field interference. That's where the Faraday cage comes in. That's how you deal with electric field interference. Humbucking deals with magnetic field interference by taking all of those interfering changes of magnetic fields from surrounding electronics, putting them through two coils, and then wiring the coils against one another so that that external magnetic variation is canceled out, while the string variation, or the magnetic field variation caused by the strings, is not canceled out. So we could not use, for example, a Faraday cage around a pickup to cancel magnetic field interference. When you put a cover on a humbucker, you're not really doing anything but protecting the humbucker. You're not really protecting the coil from electric field interference, and you're certainly not humbucking with that cover. It's more to protect the coil. So even if Eddie had used, let's say, another, like a Fender Telecaster pickup, it wouldn't have been any noisier than the Schecter. He didn't use the Schecter pickup because it cut down on noise. He used the Schecter pickup because it had 1/4-inch slugs, it was a hot wind, it had a certain tone. I think we can say he used it for tonal reasons, not because it was better than a Fender Telecaster at blocking noise. All right, so it's time to magnetize the pickup. The magnet on this one here is south. So south is facing this way. On this one, north is facing that way. And therefore, when we put our pickup in, if the top is facing the south, then the top will be north and the bottom will be south. So the pickup will take on the opposite of whatever the polarity is of the magnet itself. I'm going to put that wood block there just in case I'm too clumsy with the pickup. I don't want to have any accidents. It's already going to be tough enough, I think, to get it in there. I'm going to use, as I did last time when I was doing the humbuckers, I'm going to use a pair of pliers in connection with putting this in, because I want to have a really good grip on it. As I'm dealing with it. It really wants to pull. Well, as an example, that's what it just did. It went to the opposite side. So now I've got to basically touch them together. I don't know if you can see this or not. Yeah, okay. I'll turn it this way. I'm going to want to adjust this downward a bit. There we go. It's as far as I can really take it because of the wires underneath. There we go. That should be a fully charged, fully magnetized pickup. And with our Schecter device here, we can tell that the magnets are all, that's north up. That's what we want. And on the bottom, we should see black, which is what we're seeing. So we're good. All right, so DC resistance is nice. It's 12 k ohms right on the nose. That was a nice surprise. How's the inductance? 6.54. Pretty high for a Stratocaster pickup, but then again, this has got 0.25-inch slugs in it instead of the standard 0.187. If this turns out to be too dark, we could always wind another one. But for now, let's leave it like that. I believe that's the spec for the original Schecter, the Alnico 5s. And that gives us about 6.5 Henrys. We've got ourselves a middle pickup. All right, so clearly that is one ugly looking pickup. But it's served its purpose very well, which was to do these experiments and figure out, you know, can we get the copper ribbon on there in the first place? And if so, does it do anything? So what's going to happen next is in the next 2 episodes, you're going to see my preparation of a humbucker for the bridge position of the guitar. And then after that, I'm going to revisit the making, the thinking and the making of the middle pickup. You'll want to stay tuned for that because things are going to get radically different. That'll be about 3 weeks from now. All right, talk to you soon.